Dear students, welcome to ECA1 class. Today we will discuss Millman theorem. Millman theorem states that if you have any number of parallel voltage sources that can be reduced to 1. For example, if we have 3 voltage sources of different values in parallel, you can replace it with a single voltage source and a single equivalent resistance. These resistors are basically internal resistance of that voltage sources. So according to the Millman, you can replace all these sources, parallel voltage sources, to one single voltage source. Now let's discuss the Millman theorem procedure. First of all, for example, if we have three different sources in parallel E1, E2, E3 with the parallel resistors R1, R2 and R3. In the first step, convert all the voltage sources to the current source using source transformation theory. So when we replace this voltage source with the current source, you will see that using Ohm's law, we will write the value of the current is I1 is equal to E1 divided by R1. If we write this in term of conductance, you can write the value of I1 is equal to E1 into G1. G1 is the basically conductance, which is reciprocal of the resistance. Similarly, you can replace the second source, voltage source, to the current source, and the third one is also with the current source. In the second step, combine all these parallel sources. You will see that the direction of the current is upward. In this case, the direction of the current is also upward, and in the third source, the direction of the current is also in the upward direction. So if we consider this is a node, you will see that I1 is entering the node, I2 is also entering the node, and I3 is also entering the node. So we can replace these three current sources with IT, which is equal to I1 plus I2 plus I3. Similarly, G1, G2 and G3 are in parallel, so we can write the total conductance as GT. Now you will see that we have a simple current source here in this circuit. Now, in the third step, convert the resulting current source to voltage source and the desired single source network is obtained. You can convert that current source to the voltage source, and you will see that you have replaced the three different voltage sources to a single voltage source with a single internal resistance. Let us more simplify the Millman theory using generalized equation. If you want to find the E equivalent of the different voltage sources, we will write the equation as E is equal to I by GT. GT is the basically total conductance of the circuit. Now, if you have multiple current sources in the circuit and multiple current internal resistance of that sources, you can write the equation as I1 plus minus I2 plus minus I3 plus minus I up to plus minus IN. Similarly, for the conductance, G1 plus G2 plus G3 up to n number of conductance. Plus minus sign indicates the direction of the current, either it is an upward direction or in the downward direction, either they are entering the node or the leaving the node. So we can write that equation in the form of E equivalent is equal to plus minus E1 G1. Basically, E1 G1 is the equation of I1, E2 G2 is the equation of I2. These equations are in term of conductance. Similarly, R equivalent is equal to 1 by GT because conductance is the reciprocal of the resistor. So we can write it 1 by G1 plus G2 plus G3 up to Gn. Now, if we write these equations of a single voltage source and a single internal resistance in term of resistance, we can write it as E equivalent is equal to E1 by R1, which is the equation of I1, E2 by R2, which is the equation of I2, similarly I3 and IN. So the value of G1 is 1 by R1, 1 by R2 plus 1 by R3. We can write these equation in term of resistance. Similarly, R equivalent is equal to, this is basically the formula of the resistor in parallel, 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. Now let us solve an example in order to understand the Millman theorem. Using Millman theorem, find the current through and voltage across the resistor RL. We have to find the value of the current through RL and the voltage across that load resistance. You can see from the figure that we have three voltage sources of the different values in parallel with these three resistors. Now in the first step, we have to find the value of E equivalent. E equivalent is equal to E1 by R1 minus E2 by R2 minus sign is because of that polarity of E2. Similarly, R1 is 5 ohm, R2 is 4 ohms, R3 is 2 ohms. Substituting the value in this equation, you will get the value of E equivalent, which is equal to 2.11 volts. Now, in the second step, we have to find the value of R equivalent from R1, R2 and R3. R equivalent is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is basically the relation of the resistors in parallel. So when you substitute the values, we will get the value of R equivalent, which is equal to 1.05 ohms. Now we have the value of E equivalent, we have the value of R equivalent. Now we can find the value of VL and IL through RL. Now you can see from the figure that this is simple series circuit. Now from the figure you will see that it is a simple series circuit. Now when we are going to find the value of IL, IL is basically equal to V by RT. RT is the total resistance of the circuit which consists of R equivalent and RL. IL is equal to total voltage, which is 2.11 divided by the total resistance. Total resistance consists of R equivalent and RL. So from when we substitute the values, we will get the value of IL, which is equal to 0.52 amperes. Now voltage, if we have the value of the current, we have the value of the resistor, you can find the value of voltage, which is equal to IL into RL. So when we substitute the values, we will get the value of VL, which is equal to 1.56 volt. So this is basically the Millman equivalent circuit. So in order to apply the Millman, you must need two values, the value of E equivalent and the value of R equivalent. So you have to remember the two relations of E equivalent and R equivalent to apply Millman theorem to any circuit which consists of voltage sources of different values in parallel with their internal resistances. So that's all for today's lecture. If you have any question, comment in comment bar. Thank you very much.